let's take a look at a type of sequence and series called the arithmetic sequence and series. So arithmetic or arithmetic, if you like, sequence and series. Sequence and series. All right. This is a specific type of sequence that has a pattern to it. So let's take a look at some examples of this type of sequencer. Examples of arithmetic sequences. See if we can get the sense of what they look like. Arithmetic sequences. Examples of arithmetic sequence. All right. So for example, something like real simple. Let's start with 2, 4, 6, 8, 10, and so on. Right. 12, 14, and so on. All right. So again, these have patterns to them. Right. 3, 11. How about 19, 27? What's the next one going to be? What? Keep adding 8 to it, right? So 35, and so on, right? So obviously we see a pattern here as well. So it's increasing by 8, it's increasing by 2 on the first example, right? How about a decreasing one in terms of the arithmetic sequence? Let's start with -1, -5, -9. So each term is decreasing by what? By 4, right? So the next one's going to be what? -13, -17. And so on. All right. So these are all examples of arithmetic sequences. All right. Now the takeaway from that is what? Either increasing by some constant or decreasing by some constant. That constant is called the common difference. All right. So and how do we figure out the common difference? So let's take a look at what's called the common difference here. Common difference. Well, the common difference is simply the constant in which you're adding to the previous term to get the next term, or adding the previous term to get the next term, right? So the common difference could be positive or negative, bottom line. But to figure out the common difference, simply take what? Any term minus the previous term. So common difference is going to be any term minus previous term. All right. So up here, then, let's call that D. Common difference is going to be, we'll call D for common difference. All right. So up here, D is going to be what? For example, 4 minus 2. 4 minus 2, which is going to be 2. Or 6 minus 4, which is also 2. 8 minus 6, 2. 10 minus 8, 2. Again, any term minus the previous term. All right. Likewise here, what's the common difference on the second one? Well, that's 11 minus 3, for example, right? Or 19 minus 11. So 11, usually we'll just take the second term minus the first term, and that's good enough. And so the common difference is 8. So we keep adding 8, hence, right? The common difference here is negative since it's a decreasing sequence, right? So for this arithmetic sequence, it will be what? -5 minus -1. That's -5 plus 1, or -4. For this common difference on this example here, all right? The key is what? If a sequence of numbers has a common difference, that means it's an arithmetic sequence, all right? And since it has a pattern to it, then we can certainly have a formula that we can use to find a certain number of terms, all right? So let's go and get to that formula here. So let me go and clear out the screen, all right? So for an arithmetic sequence, for an arithmetic or arithmetic sequence. All right, let's call the sequence A1, first term is A1, A2, second term, A3, third term. We've seen that already from previously, right? Let's say what is the nth term? All right, the nth term again is called the general term, right? If we'll recall that, all right. So what is the general term here? Well, here's the formula. So an is just based on the first term and the common difference. So the nth term is going to be the first term plus n minus 1 times the common difference, D. Right, D is our common difference. Oops, let me try to circle that properly there with the sketch pad, all right? So keep this formula in mind. The nth term is what? The first term plus the quantity n minus 1 times the common difference, D. So for example, if we go back to our previous arithmetic sequence, let's say 3, 11, 19, 27, and so on, right? Let's go ahead and find, let's say I want you to find the 36th term. Find 36th term, or A36 in this case, right? What is the 36th term of this sequence here? Well, step one, we need to what? Figure out the common difference. We did that already. Just simply take the second term minus the first term. And that's going to be 8. No big deal. All right. Now, then what's n then? Well, we want to find a 36 term, so n is going to be 36. So write down n equal to 36 for this problem. So A36 is going to be what? The first term. Well, A1 is the first term, so let's write down A1 as well. That's just 3, right? So 3 plus 36, that's n, right? Minus 1 times the common difference of 8. All right, so that's going to give me what? 3 plus 35, right? 36 minus 1, right? Times 8. All right, that's going to be 3 plus what? 35 times 8 is what? I'll punch the calculator, 280. So the 36 term, if I keep writing this out, the 36th number of this sequence, of this arithmetic sequence, will be what? 283. Right, this is the 36th term in this sequence. All right, let's go and try another one here. Let me go and clear out the screen. So keep that formula in mind again, right? So again, let's look at the one we had in terms of a decreasing sequence: -1, -5, -9, and so on. Right? Let's go ahead and find the 57th term. A57 here, A57. So find the 57th term of this list here of numbers, right? So again, let's identify the key components again. First of all, let's write the formula down again. AN equal to A1, so write the formula down, help you memorize the formula quicker, times n minus 1 times the common difference, all right? That's the nth term. So A1 was what? First term, -1. All right. What's the common difference? Well, common difference is what? -5 minus -1. Second term minus the first term, or -9 minus -5. So it's up to you. But I just take the second one minus the first one. So -5 minus -1. Now again, that's going to be -5 plus 1, or -4. So that's the common difference, -4. All right. So and what's n? Well, I want to find the 57th term. So n is 57. All right. Just plug it into this formula then. So A57, 57th term is going to be what? -1 plus 57 n minus 1 times -4, the common difference. All right, so that'll give me -1 plus 56 times -4. No big deal there. All right, so that's going to give me -1 plus what? What's 56 times -4? That's going to be -224. All right, so therefore the 57th term is going to be what? -225. All right, so again, pretty easy to find a certain number of a certain term in a sequence if it's what? An arithmetic sequence because of this formula here. All right, let's take a look at a different problem based on this formula. Let me go and clear out the screen. Suppose I give you a sequence of numbers such as 7, 9, 11. And let's say the last term of this list so this is a finite sequence, so it stops at what? Let's say it stops at number 59. All right? So I want to know how many terms are in here. So find the number of terms. Find the number of terms on this list. How many numbers are in there? All right? In other words, you want to find n. Right? In other words, find n basically, right? Again, we use our formula an is equal to a1 plus n minus 1 times the common difference. Again, we know that a1 is equal to 7. That's the first term. Common difference is going to be what? 9 minus 7, or just 2. All right, so we know d and a1 immediately. We're asked to find n. So, but look at this an here. Well, an, this is going to be what? We're going up to the nth term. So this is my an. All right, this is the last number that we're going up to. So, and we want to find out what is that on the list of numbers here, right? In other words, what term is that? This 59. So let's plug in 59 for an. So we're saying that an is equal to 59 for this list of numbers here. All right. So let's plug it all in. So we're going to get what? 59 equal to what? 7 plus n minus 1. So we're solving for n here in this case, right? Times what? Times 2. D, the common difference. All right. So let's subtract 7 on both sides. Solve it any way you like, right? So 52 is equal to n minus 1 times 2. All right. Just divide both sides by 2 here. So divide out the 2. So that's what? 26 equal to n minus 1. So adding 1 to both sides, we see that 59 is the what? 27th number here, right? So n is equal to 27. So that's the 27th number on this list. So there are 27 terms in that sequence. All right? So we can certainly use this formula to find out the number of terms for a finite sequence. Notice, a finite sequence is a list of numbers that comes to an end. All right, so not too bad at all. Now let's take a look at the take a look at using this form to find the general formula for a sequencer. So, for example, let's go ahead and take a look at this problem here. Let me squeeze in here if you don't mind. Then, how about this list of sequences? -3, 1, 5, 9, and so on. All right. I want you to find. Oops, sorry about that. Find the nth term. Give me a formula for the nth term in terms of n. Find a sub n. Well, again, we can use this formula, right? So a1 is going to be -3. I said -3 there, sorry about that. And the common difference is what? Well, we can do 1 minus -3, but how about 5 minus 1? I'll just do the third term minus the second term, that's fine. 5 minus 1, which is going to be 4. Again, the common difference is what? Take any term minus the previous term. So it could have been 9 minus 5, right? So this thing is increasing by 4, by the way, as you should see at this point. All right. So anyways, let's go ahead and look at the nth term. So a sub n, it just uses formula again, right? Is going to be what? -3 plus n minus 1 times 4. All right. Now the answer should be in terms of n. So let's simplify this expression right here. So that's going to be -3 distributed 4 plus 4n minus 4. All right. So we're going to get what? 4n minus what? Minus 7. Is the nth term, is the formula for the nth term in this arithmetic sequence here. In this arithmetic sequence. All right. So a 4n minus 7 is the nth term. Okay. So we can use the formula for finding the number of terms in a finite sequence and also finding the general formula for the nth term. All right. Let's take a look at the sum of an arithmetic sequence here. Right. Let's say I want you to add up a certain number of terms in an arithmetic sequence here. So, so let's go ahead and clear out the screen here. Let's take a look at the sum of n terms in an arithmetic sequence. So here's the formula for that. It's going to be n over 2. So use this formula times the quantity a1 plus a sub n. All right. So in other words, to use this formula to find out the sum of a certain number of terms in an arithmetic sequence. Again, you can only use this formula if it's an arithmetic sequence, meaning that it has a common difference. That is right. So all we need is what? All we need to know is what? How many terms we're adding up, the n, and also the first term, and the term that we're adding up to, or the last term that we're adding up to, the nth term. So here's what I mean by that. Let's say I give you the same sequence we had earlier here. Let's say it was -3, 1, 5, 9, and so on. All right. I want you to find the sum of the first 25 terms. Find S25, right? Add up the first 25 numbers here, all right? So obviously we can use this formula then, right? So how do we go about doing that? Well, we have to know two things. First of all, we know that n is going to be what? 25. So we're adding up 25 numbers. So n is equal to 25 right off the bat. A1, we know the first term, right? There's A1, right? Right here, -3. So A1 is going to be -3. No big deal there. We need to find out the last term that we're adding up to. In other words, what is the 25th number out here that we're adding up to? Well, first thing we have to do is what? Find A25. But that's not too bad because we saw the formula we had earlier, right? Of finding the nth term, which is A1 plus n minus 1 times the common difference, right? So we have this formula. So we're incorporating both formulas for this particular problem when you're finding the sum of a certain number of terms for an arithmetic sequence. All right. So let's go ahead and do that then. What is the 25th term then that we're going to add up to? Well, let's use this formula once again. So A25 is going to be what? -3 first term plus 25 minus 1, that's n by 25, times the common difference. What's the common difference? Well, common difference is what? We did that earlier, 5 minus 1, or 4, right? Common difference is 4. This thing is increasing by 4, right? So times 4. So this is going to be what? -3 plus 24 times 4. This is going to be -3 plus what? 96. All right, 24 times 4, 96 there. And that's going to be 93. All right, 93. So the 25th number is 93 here in this list of numbers. All right. So now we have what we need. So therefore, the sum of the first 25 numbers will be what? 25 over 2 times the first term, -3, plus what? the 25th number, which is 93 in this case. All right, so 93 is what we're going to plug in for a sub n. All right. All right, let's go and work it out. So this is going to be 25 over 2. We could punch it as a calculator at this point if you want to, but I'll just show a little more work here. That's going to be what? 90, 93 plus 93. That's going to be 90 there. All right, so 2 into 90, 45 times. So 25 times 45 on my calculator is going to be 1125. So we get 1125. So the sum of the first 25 terms is going to be 1125. All right, so we're using both formulas here to find the sum of the first 25 terms. All right, so no big deal there, if you will. All right, let's try another one. I'm going to clear out the screen. Let's go and find the sum of the. Let's give you this list of numbers. How about let's do one we had earlier: -1, -5, -9, and so on. All right, let's find the sum of the first say 38 terms. Let's find S38. All right, sum of the first 38 terms. All right, so again, we're going to use both formulas. So let's write the formulas down just to recap. N over 2 times A1 plus AN. There's the sum formula. AN, the nth term, is going to be A1 plus, that's an A there, sorry about that, N minus 1 times the common difference. All right, so anyways, let's go ahead and figure out what we need here. So we know the common difference here was what, -4. We figured it out earlier, but oops, let's do it again. -5 minus -1, second term minus first term, -5 plus 1, or -4 that we figured out earlier. All right, first term is going to be what? -1. No big deal there. And I need to know what the 38th term. So let's figure that out. A38. Okay, so A38 is going to be what? A38 in this case will be using this formula here, right? A sub 38. So -1 plus 38 minus 1. That's a 38 there. Sorry about that. Times -4, the common difference. So that's going to be -1 plus 37 times -4. All right, so 37 times -4. So that's going to give me -1 plus -148, or -149. So the 38th number on this list is going to be -149. So now we have enough information to plug it into the sum formula. So S38 will be equal to 38 over 2 times the first term, -1, plus the term we're adding up to, the 38th term, which is -149. All right, so that'll give me what? 30 over 2 is 19 times -150. 150 there, right? Adding these two integers together, so we're going to get equal to, so 150 times 19 on the calculator. 150 times 19 on the calculator will give me 2850. So that'll give me -2850 if I punch that into the calculator to get the answer. All right. So again, no big deal here. Incorporate both formulas into a problem of this type. All right. Now let's take a look at a sum given in sigma notation. How do we figure that out? Let's go and try this one here. Let me go clear out the screen. Let's say I want you to evaluate this sum. So evaluate sigma notation. How about sigma of n going from 1 to 18. So we're adding up the first 18 numbers here of the formula 3n minus 2. Right? So let's go ahead and again use the sum formula. Sn equal to n over 2. N over 2 times a1 plus an. Now this one is actually not too bad because you're given the nth term in this sigma notation right here. This is my an. All right, this is the an. All right. So in that case, then all we have to do is what? We don't have to use the an formula at all. We just have to plug in the n to get the first term and what? And the 18th term. So let's go ahead and find before we. First of all, n is going to be what? 18 because we're adding the first 18 numbers, right? So n is equal to 18 first off for this problem. 18 there. All right. Now let's find a1, the first term, as well as the 18th term, a18. And we simply have to plug it in, plug in 1 for n to get the first term. So a1 is going to be 3 times 1 because we're given this nth term formula, right? So we're told that an is equal to 3n minus 2, so just plug it in. So 3 times 1 minus 2, so that's going to be 1, right? 3 minus 2. The 18th term, right? I need to know the term I'm adding up to, the 18th term. That's going to be 3 times what? 18 then, right? Because n is 18, right? Since, again, we're given the formula here, right? Minus 2. That's going to be what? 54 minus 2, or 52. All right? So we have the first term and the last term we're adding up to. We can now plug it into the sum formula. So S, in this case, S18, which is what this sigma notation is, that we're adding up the first 18 numbers, is going to be what? 18 over 2, n over 2, times what? 1 plus 52. Or 53, if you like, right? So it's going to be 9 times, 18 over 2 is 9 times 53. Let's punch onto the calculator, 9 times 53, and that's going to be 477. All right, so we can also evaluate sigma notation using this sum formula. Okay, so again, this only works if we have what? An arithmetic sequence, which is basically a linear sequence, right? 3n minus 2, that's basically linear, right? Just think of this as mx plus b almost, right? All right, so hopefully not too bad in terms of the concepts here. Let me give you some problems to post answers to into Blackboard here. Then go and clear up the screen. All right, so number 1, I want you to, given this sequence here of 3, negative 4, negative 11, and so on. All right, given this arithmetic sequence, I want to figure out the common difference, and what have you, right? I want you to find the sum, though. Find the sum of the first, let's say, 50. Sum of the first 59 terms. Find S59. All right, sum of the first 59 terms. All right. And number 2, I want you to look at a savings problem. Let's look at a savings problem. Savings problem. Well, here's a little word problem for us, right? Suppose we save. Suppose we save $1. $1 for on day 1, all right, and then save. Let's say we save $2 on day 2, or let's say we save $3 on day 3, and so on, and we do it for 30 days. All right, so on the 30th day, so on day 30, basically for 1 month, right? 30 days, right? 30th day we save $30, right? So let's go ahead and find the total savings. Find total savings for the 30 days. All right, so hopefully not too bad. And last but not least, let's give you another formula, another problem here. So let's take a look at this arithmetic sequence: negative 12. Negative 10, negative 8, and so on. I want you to find the nth term. Find the nth term in terms of n for this arithmetic sequence. All right. So work it out carefully using the formulas given, and post answers into Blackboard. Then. All right. So until next time.